we want to take the definite integral of 3 plus 8x cubed minus e to the t dt from 0 to 2. So notice that our variable is t here, and our variable is t here. Those match. So we're integrating this function with respect to t. This is a pretty straightforward integral. We just need to know the fundamental theorem of calculus part 2. It says that if you've got this function which is a well-behaved function, you can find an antiderivative of it, which is 3t plus 8t to the fourth divided by 4 minus e to the t, and evaluate it at 2 and 0. Subtract the results, and you have your solution. So we have 3 times 2, 8, and 4 with a 2. Okay, so 2 times 2 to the fourth minus e to the second. That is our big F of 2 minus, now we have to do big F of 0, 3 times 0 plus 2 times 0 to the fourth minus e to the 0 is 1. So we've got 6 plus, I think that's 32, minus e to the second minus a negative 1. So it looks like 39 minus e squared. And that's my solution. For the next one, part B, I would also like to use fundamental theorem of calculus part 2. But it's a quotient, and I don't have quotient rule for antiderivatives or for integrals. So I want to do a little bit of algebra first and then find the solution. So I've got the integral from 1 to 4, and I'm going to rewrite this as x to the fourth divided by x minus 3x to the 1/2 divided by x dx. And that's what I want to work with. I'm going to simplify this so that it becomes a power rule type problem that I can work with. X to the fourth divided by x is simply x cubed. X to the 1/2 divided by x is x to the negative 1/2. Now that I've got just some power functions, I can use power rule. So add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. And when we divide by a fraction, we multiply by the reciprocal. Evaluate it at the values. Notice that in this problem, x equals 0, the function was not continuous at x equals 0. But that's not going to cause any problems here, since our interval from 1 to 4 does not cross x equals 0. If it had, we would have problems that we would not at this point know how to deal with. So we have 4 to the fourth divided by 4 minus 6 times the square root of 4 minus 1 to the fourth divided by 4 minus 6 times the square root of 1. And then from here, I would probably start typing things in my calculator. 4 to the fourth divided by 4 is 4 to the third. 4 to the third, what is that, 64? Maybe? I'm guessing. You should check my numbers there. 6 times the square root of 4 is 12. Minus a quarter plus 6. And I don't feel like adding that up, but that is our solution. Whatever fraction that is will give us our solution. But the key here is, in order to work this problem, you've got to deal with the fraction part, with the x's in the denominator, before you can proceed to do the power rule for integrals.